In this video, we'll show you how to adjust the valves on your 4-stroke motorcycle or ATV. We'll need a few different tools to complete this job. First, we'll need a feeler gauge so we can measure the clearances, and Rocky Mountain has a few different options for you. Next, we'll need a few standard tools so we can get to the valves, but most importantly, we're going to need our service manual. This contains the very important, very specific specifications you need for this job. It's also very helpful to have a caliper to measure the thickness of each valve shim. We're also going to need some valve shims. Rocky Mountain has these available in shim kits with numerous different sizes, or you can buy them individually if you know which sizes you're going to need, but we'll get to that a little later. It's a good idea to start with your piston at top dead center. Refer to your service manual for this, but most of the time there will be a mark on the flywheel that needs to be lined up with a mark in the top hole. You'll see our piston is currently at top dead center. So first things first, we're going to want to start with a clean bike. It's always easier to work on a clean motor, and also keep in mind that each machine is different. This process will vary from machine to machine. Today we're working on a 2007 Yamaha WR250F. First thing, we're going to remove this seat and the tank. After that is the spark plug cap and the valve cover breather hose. After that, we're going to remove the 2 bolts from the valve cover. Usually there's just 2 of these bolts, but sometimes you'll find 3. So once those are removed, we can just remove the valve cover. And that will reveal the valve train. So now we can start measuring our valve clearances. We're going to need our feeler gauges now. And to measure the valve clearance is simple. All we're going to do is take the appropriate feeler gauge and slide it in between the camshaft lobe and the valve bucket, which is also known as the tappet. You want the gauge to feel almost sticky underneath the cam lobe. If the clearance is bigger than the gauge, it will slide in and out easily. If the clearance is smaller than the gauge, you'll know because the gauge won't slide in at all. For illustrating purposes, we've removed our cylinder head from the bike to better show the adjustment process. So removing the head is not required, and the steps that are shown will be the same as they would with the head still on the motor. We need to refer to our service manual and figure out what our valve clearance service limits are. That will tell us what size feeler gauges we need to be using. As you can see, the service limits for this WR are 0.1 to 0.15 millimeters for the intake and 0.17 to 0.22 millimeters for the exhaust. Most all motors will have service limits similar to this motor. So we're going to start with the exhaust side. We're using our 0.20 millimeter feeler gauge, and as you can see, it's sliding in under both of the lobes, but not very easily. So we're going to grab our 0.18 millimeter gauge, which is a little smaller, and try that one. You can see that it's a little sticky, and that's exactly what we want. So we're going to record that measurement because we'll need it later on. So the right side measured 0.18 millimeters, and the gauge went in a little easier on the left side, so we're going to record that as 0.19 millimeters. And now we can start measuring the intake side. So we're going to start with our 0.15 millimeter gauge because it's the top of our service limit for our intake valves. As you can see, it slid into the right side just fine. Moving to the middle valve, you can see that it won't slide in at all, and that's the same case for the left intake valve. So we're going to move to our 0.13 gauge, and it looks like it's fitting perfect in the right side. The left intake valve and the middle are still not fitting, so we're going to record the measurement for the right intake valve now at 0.13 millimeters. So now we're going to go to a little smaller gauge to see if we can't find the clearance for the left valve. We're using a 0.06 millimeter gauge, and that slides in just fine, but the 0.07 millimeter gauge fits perfect. So we can record that clearance for the left valve now at 0.07 millimeters. After that, we're going to take our 2 smaller gauges and see if there's any clearance in the middle valve. As you can see, nothing is fitting between the lobe and the bucket, so we can record the middle valve as having 0 clearance. So now that we've got our clearances measured and recorded, we can begin removing the camshaft so we can get to the valve shims. First step would be to remove your cam chain tensioner. Keep in mind that yours will most likely be a little different than the one shown in this video, so refer to your service manual for proper procedures. Next step is to tie a wire around the cam chain so it doesn't drop down into the motor when the camshafts are removed. We can tie that up around the handlebars. And now we're loosening the camshaft cap bolts. Remember to loosen these in a crisscross pattern to prevent causing any damage. After the bolts have been removed, we can pop the camshaft caps off. Remember, there are usually a couple of lining pins in each cap and a lining clip that need to be removed to prevent them from falling down into the motor. After we've removed the caps, we can go ahead and remove both the intake and exhaust camshaft. Doing this will reveal the valve buckets. The next step is to remove the valve buckets and shims. A magnet works best for this and ensures that you don't drop anything down into the motor. Remove each bucket and shim and organize them on your table so they won't get mixed up. Sometimes the shim will stay kinda stuck up inside the valve bucket, and other times it will stay sitting down in the spring retainer, so pay attention so you don't lose them. So we've got both exhaust buckets and shims removed and placed on the table. We're going to do the same thing for the intake side. Just grab the bucket with the magnet, make sure you've got your shim as well, and then place them on the table. You want to make sure you're keeping everything organized between your motor and the table during this whole process. This is a very critical part to a valve adjustment. Now we're going to clean everything up with a rag really quick to make it easier to work with. It's time to refer to the specs from our service manual. Once again, you'll see the intake is 0.1 to 0.15 millimeters and the exhaust limit is 0.17 to 0.22 millimeters. We need to check the clearances we've recorded and see which ones are still in spec and which ones need to be adjusted. As you can see, both our exhaust valves are still in spec at 0.19 and 0.18 millimeters, which is right in the middle of our bracket, and the right intake valve is still in spec as well at 0.13 millimeters. So now we need to look at our other two intake valves and figure out the correct size shim to install to get our desired clearance. To figure that out, we need to know what size shims were in the head. This is where a caliper comes in handy. All valve shims have their size printed on them, but sometimes that number can get worn off, so if you're unsure of what size the shim is, simply measure it with a caliper. As you can see, our left intake valve shim is measuring 1.7 millimeters, and our middle intake valve shim is measuring 1.63 millimeters, so we're going to write that down. So with our left valve, we need to go down on the size of the shim to get more clearance, because right now it's at a 0.07 millimeter and it needs to be between 0.1 and 0.15 millimeters. So if we get a 165 shim, which is 1.65 millimeters thick, the difference between that and the 170 that was in it is 0.05 millimeters. If we add that clearance to our current 0.07 millimeters of clearance, we should get 0.12 millimeters, which is in spec, so we'll swap that 170 shim out for the new 165 shim. And since our middle valve has zero clearance, we're going to use the biggest service limit for the intake, which is 0.15 millimeters, and subtract that from the shim size that was in it. So 1.63 minus 0.15 millimeters equals 1.48. And since they don't make a shim that size, we're going to use a 150 shim. So we can go ahead and swap that shim out. Okay, so now we've done the math to get our new shim sizes on the two intake valves that needed adjustment. We need to put our cams back in to check those clearances again. So now we're reinstalling each shim and bucket back into their correct location. When installing the shim, be sure it seats down all the way to the end of the valve, and then slide the bucket down over the shim. Repeat this process for all the valves. After that, we're ready for the camshafts and camshaft caps. Don't forget the locating clip and make sure your dowel pins are in place as well. Do this for both cams if applicable, and make sure everything seats correctly. We can reinstall the cap bolts and tighten those down. It's a good idea to refer to your service manual for this to avoid causing damage. You'll want to tighten these bolts in a crisscross pattern. After you get those tight, make sure the camshafts rotate smoothly. If they do, we can rotate the lobes back up to where they sit at top dead center. This will allow us to get an accurate clearance reading. We're using our 0.13 millimeter feeler gauge, and it seems to fit about perfect with our left intake valve, but it still won't fit under the middle intake valve. But if we drop down to a 0.07 millimeter gauge, it fits, so at least it's measurable now. So now the new measurement for the left intake valve is 0.11 millimeters, which is in spec, and the new measurement for the middle intake valve is 0.07, which is still not in spec. So if we swap that shim for a 145 shim, the difference of those two is 0.05 millimeters, and if we add the current 0.07 millimeters of clearance to that, it equals 0.12 millimeters of clearance, which is right in spec. We need to remove our camshaft cap again and remove our intake camshaft one more time to swap the middle valve shim out for a new 145 shim. So after we've removed the 150 shim from that, we're going to sit that 145 shim down into place and replace the bucket on top of it. After that, we can reinstall the camshaft and camshaft cap, and once again tighten those bolts down. And when we measure it again, it should measure something like 0.12 millimeters, which it does. So now all of our valve clearances are within spec. We can start putting the motor back together. First step to that is timing the motor. So we need to remove the engine plugs from the left crankcase cover. The bottom plug is so you can get a socket in there and turn the motor over if needed. The top hole has the aligning mark and shows the mark on the flywheel, and as you can see, both marks are lined up, telling us the piston is at top dead center. If you don't see the mark on the flywheel, you need to turn the motor over until both marks line up. You're going to want to pop your camshafts out one more time and apply a little assembly lube to the lobes and journals of each camshaft. We need to refer to our service manual for proper timing instructions. As you can see, each cam sprocket has timing marks on them. So we're going to need to refer to our service manual to get the camshafts in the correct position. It's important to start with the exhaust cam and pull the cam chain tight up off the crankshaft so there isn't any slack. Align the timing mark where it needs to be, and then run the cam chain over the intake cam and align those marks accordingly. It's basically starting at the front of the motor and then working your way back. The slack in the cam chain will be taken up by the tensioner. So we've got our camshafts installed and timed using the mark on the flywheel and the marks on the camshaft sprockets. Go ahead and double check your work according to the service manual. Make sure everything is how it should be. Remember, the cam chain tensioner will not be installed until a little later. So now we're going to install our camshaft caps. First we set the locating clip down onto the bearing. Be careful not to drop it. And then make sure we've got our 2 dowel pins still in the cap and set that down onto the camshaft. It should just pop into place. And then we're going to do the same thing for the exhaust side. Sit that locating clip down into the groove on the bearing, and then sit the camshaft cap down into place. Then we can put the camshaft cap bolts into place and begin tightening those down. Again, we need to tighten these and torque these bolts in a crisscross pattern to avoid causing any damage. Refer to your service manual for proper torque specs. So after those have been properly torqued, we can go ahead and put those 2 engine plugs back into place and tighten those down. Now that those are tight, we can install the cam chain tensioner. Remember that your tensioner may require a little different install than this one did, so be sure to refer to your service manual for this. The next thing we're going to do is apply a light coat of silicone to the cylinder head surface. That's going to help the valve cover seal a little better. Then we can just set that valve cover up into place. You'll notice we've already got the gasket on the top part of it. Then we can reinstall the 2 bolts on top and tighten those down. The next thing we're going to do is reinstall our spark plug cap. Now we're going to slide that cylinder head breather hose down into place and route that accordingly. After that, we're going to reinstall the tank, tighten those bolts down. And once the seat's installed, we're done with this valve adjustment. If you have any questions, call in or visit our website. Rocky Mountain ATV MC is the leader for parts, accessories, and apparel for your UTV, ATV, and motorcycle. Thanks for watching.